Okay, so today's date 3/22/18. I don't know, I'll try. Common Core Standard has to do with variations. We're going to look at direct variation, inverse variation, and we're even going to do joint variations, okay? So, first of all, here's our formula. If it's a direct variation, it has this formula, y equals kx. Looks a lot like this. Looks like a lot like y equals mx. So really the value k and m are the slope of the same thing, okay? So always goes to the origin, so you can always put like a plus 0 here, okay? If it does not go through the origin, it's not direct variation. If it's not straight, it must be straight, must be a straight line, and it must go through the origin, okay? If it doesn't do either one of those, it's not direct variation, okay? So, the key to doing this is to find, little star, find k first. Find the value of k first. That's what we're going to do almost throughout this whole lesson. So we're going to find the value of k first. Okay, so first of all, example 1. If y varies directly with x, so if it does, we're going to use that equation. Okay, just the words, if y varies directly, so it's direct. It is direct variation. The word says directly, so it's that equation. Okay, when y is 14 and x is 3.5, so let's plug those in to my equation. So this is the equation I want to use. I want to use y equals kx. I'm just going to use my equation, my variation equation. We'll go 14 equals k times 3.5. So I'm just plugging the 14 in for y. And I'm plugging the 3.5 in for x, right? So I'm going to just use the equation to find k. All right, that's easy. Divide by 3.5, divide by 3.5. And what is 14 divided by 3.5? I don't know. I'm going to find out, though. 14 divided by 3.5 is 4. So k equals 4. So I can rewrite this equation as y equals 4x. There's my equation, right? Now I can graph this in a couple of ways. One, I can graph it, I'm going to graph it two ways. One, just with the information. If y is 14 and x is 3.5, I go 1, 2, 3.5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's way up there's 1 point, even though it's off my graph. And I have a second point. Has to go through 0, 0, right? Has to go through 0, 0. Has to go through 0, 0. So my other point is 0, 0. Or, I know how to graph this equation, don't I? This equation, I would start at 0, and I'd go up 4 over 1, up 4 over 1, up 4 over 1. So it's nothing that we haven't seen before. It's just a different name for something that we've been doing for some time. That is a direct variation. As one value gets bigger, the other gets bigger. As the other gets bigger, the other gets bigger, right? X directly influences y. Okay?
With the direct that, it always has to go by 0, 0, right?
Yes, 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 yes. Awesome, well said. Direct variation always goes through 0, 0. And if it doesn't, it's not direct variation. In fact, that'll be on your homework today. You'll look at graphs and things and say, nope, nope, doesn't go through 0, 0. Not direct variation, okay? In fact, neither one of them go through 0, 0, right? We'll see. Okay, so example 2, inverse variation, okay? So, if it's inverse variation, we want to use this formula, okay? So we're going to use our x, y equals k. And let's find k, all right? Let's find k. So x is 2, y is 3. So the value of k is 6, right? And since it says inversely varies, I'm going to use this formula here, right? So I'm going to rewrite my equation as x, y equals 6. How do we graph this? This graph is going to look like this. This graph's going to look like this, except for the multiples of 24. It's what times what makes 6. Okay, we know 3 times 2 2, and we know 2 times 3. You agree with that? So it's really what times what equals 6? Well, 3 times 2 and 2 times 3. We also know 6, 1, 2, 3, 4, 5, 6, and 1. We know 1 and 6. 1, 2, 3, 4, 5, 6, right? Cannot equal 0. We know that. I know, I do that often. I'm sorry. Okay? Right? Now, we also know a negative times a negative makes a positive also, right? So I know a negative 3 times a negative 2 makes 6. I know a negative 2 times a negative 3 makes a 6. I also know a negative 6 and negative 1. 1, 2, 3, 4, 5, 6 and negative 1. And also a negative 1. And a 1, 2, 3, 4, 5, 6 also makes a positive 6. And so here is my other half of my hyperbola. Okay, that's a hyperbola. You don't need to know the word yet, but I'll just keep using it just to keep you knowing, okay? We know that x cannot equal 0. We know y cannot equal 0, right? Which means then we do have asymptotes here and here. So we have an asymptote at x equals 0 and an asymptote at y equals 0. Okay? Thumbs up?
No.
I'll wait for you. Okay? So if it is inversely, we use the xy. What times what makes 6? Lots of combinations, right? But not 0. 0 won't work. 0 times anything, 0. It's not going to be 6, right? Okay, shift the page, move it up. You ready? I'll wait for you. Renee, give me thumbs up when you get it, okay? Okay.
Good.
Avi, you got it?
Yeah.
Okay, slide it up. Okay. So now, words. But let's not let the words bother. So, a couple of keywords. First of all, varies. Okay, first keyword, varies jointly. Okay, there's first keyword. Okay, so I need some more variables. Okay, so first variable, I have A for area. Okay, I've got a B for base, and I've got an H for height. Okay, so I already know the answer, but let's work it out and see what. I already know that the area of a triangle is equal to 1/2 base times height, right? I know that. You guys agree? Area of a triangle? I already know then that K is 1/2. I already know the answer, but let's do the math. I picked this one on purpose. I picked one that we already know the answer, but let's do the math and show why it's got to be 1/2, okay? So I already know K is 1/2. I already know the formula. But let's just assume we don't. Let's do the math and see how it works. Okay, so the area of a triangle varies jointly as the base B and the height H. Okay, so I'm going to write A equals K times B times H. Because if it varies jointly, we're going to have 3 or more variables. Okay, so then we got to solve for K, right? So we have some more information to help us out. The information we have is here. We know that the area is 12 when the base is 6 and the height is 4. Okay, so let's plug those in. Put 12 in for the area. We'll put 12 in for the area. I don't know K because I want to solve for K. The base is 6 and the height is 4. And I'm going to solve for K. Now K is 1/2, but we're going to see it, right? We already know the formula, but let's just prove it, okay? So 12 is equal to K times 24, right? Divide by 24, divide by 24. 12 over 24 is 1/2, okay? So I just showed or proved something we already knew, but I wanted to show you how it works. So then I can rewrite my equation. So now my equation really is A equals 1/2, because that's K, base times height, right? There's my equation. I found K. Yes, I already knew what it was, but it showed that it is 1/2. Okay, now, there's more information. So it says find B if now we change the problem around. If the area is 36 and the height is 8. Thanks, Katie. So now, let's use our equation. So, my equation is area equals 1/2 base times height. Let's use our equation. 36. And that's the equation here that we just discovered, which we already knew. Area is 36. The base is, we don't know, b, and the height is 8, right? We're just going to solve for the base. Jacob. Yeah, thanks. I zoomed it in pretty far, didn't I? Yeah. So, half of 8, I'm going to do this first. Half of 8 is 4, right? Half of 8 is 4. You okay with half of 8 is 4? Divide by 4, divide by 4. And the base has got to be 9, right? There we go. Not too bad. The trick to this assignment has to do with the words. Direct variation, that formula. Inverse variation, hold on, that word. Joint variation, we know it's 3 or more variables. And we're also going to have this, there's one more. What's in the reading, that last one I gave you? What's that last one? Yeah, combined variation, which could be direct and inverse. Okay, turn the page. You guys ready for me to turn the page? Okay.
Wait, what exactly is joint?
Joint is like when you've got more than one variable. And that's where I got 1, 2, 3 variables. I got more than 2 variables. Okay, good question, okay? Okay, turn the page. Now, number 4. I think the best way to answer these, if I can see it, I can do it. If I can see it, I can do it. You guys agree with that? Yeah. Picture tells 1,000 words. So example 4. I'm going to graph it, okay?
We can't see it very well.
I can't zoom out, but I might have to go by 2s. Maybe I'll go by 2s. I might go by 5s. 5, 10, 15, and guesstimate 5, 10, 15, 20, 25, 30. Okay, so there is one way to do this. I think the easiest way is to graph it because you can see it. So I'm going to have a graph at 3, 9, which is about there. I'll have a point at 8, 24, which is about there. And 10 and 30, which is about there, okay? What do you notice about those? I've already connected the dots. What can you tell me about the line?
It goes like,
I've already connected the dots. What can you tell me?
it goes like this with direct variation.
It is direct. 2 things. You said one of them. 2 things. One, is it straight? Is it straight?
Yes.
Because it has a constant slope, which I'm going to show that in a second. It's straight, and Tammy said, what does it go through? The origin. So we know this graph has to be a direct variation. Now, another point is 0, 0. Because you can see the slope. And I'm going to show you the slope all the way through. This one's up 5. And this is up 15. This is up 2, and this is up 6. My slope is going to be 15 over 5, which is 3. My slope is 6 over 2, which is 3. So it has a constant slope, which means it must be straight. Up 3 over 1, up 3 over 1, up 3 over 1. And even on my graph, if I went from here down 3 over 1 and put me right at 0, 0, wouldn't it? Okay. All right, now, how about example 2? How about this one? Well, let's graph it. I think the best way to do is take a look at it. What does it look like? So, picture's worth 1,000 words, right? All right, let me go by, I'll go by 5s again. 5, 10. I'll just be careful where I put the points. 5, 10, 15. So I got a point at 4.5 and 8. About there, right? I got a point at 12 and 3. I got a point at 2 and 18. Okay, what do you see? Does it look straight? It's curved. So which one do you think it is?
Inverse.
It is my inverse variation. Now, can I prove it? You bet I can prove it. An inverse variation formula is x times y equals some number, okay? Equals some number, okay? All right, so if I want to prove it, that it is inverse, it looks like inverse, doesn't it? Right? It looks like it kind of curves. All right, calculator. What's this times this? What is 4.5 times 8? I don't know. What is 4.5 times 8. 36. What's 12 times 3? What's 2 times 18? So when I multiply x times y, x times y, x times y, I get the same value, right? So this is like x times y equals 36, which makes it all the combinations to make 36, which has to be an inverse variation, right? But by graphing it, you can really see it when you graph it. You guys agree? You get a real good picture, okay? Last example. Not too bad so far, right? And when I get done, I want to review a couple of concepts, okay? Number 5. So look for the key words. Anytime you have a story problem, dissect it, okay? So here's a key word right here. Yes, that's a key word, okay? Inversely. So right off the bat, I know I'm going to go x, y equals k, all right? Okay, right off the bat, inversely. Okay, you guys see the key word inversely?
Yeah.
Except for I'm not really going to use x and y because this thing has to do with volunteers and hours, right? Volunteers and hours. So I'm going to use, instead of xy, I'm going to use v h equals k because I'm talking about volunteers and I'm talking about hours. Okay, same equation, different variables, right? So our first step was to always find k, right? So let's find k. So step 1, got to find k, all right? Oh, thanks, Katie. So we're going to find k. So let's take a look at what we know, okay? So I'm going to have to slide it back over in a second, Katie, okay? So let's see what we got. So if I have 20 volunteers, I'll put 20 there. I can build a house in 62.5 hours, okay? So 20, go here, and 62.5 equals k. All right, you guys ever see that? I know you guys have all seen the show where they build a house like in a weekend or whatever, right? Totally makes sense, right? If I have 100 workers, we could get the house done in a week. If I have 2 workers, it's probably going to take me a year, right? So the more workers, the less time. The less workers, the more time. So it's inversely proportional, right? So one gets bigger, the other gets smaller, okay? Anyway, let's solve for k. That's easy. It's 20 times 6.62.5. I don't know. 20 times 62.5. I get 1,250 is equal to k. So we need all the combinations of 1,250. So my equation is VH equals 1,250. Okay. Okay, now we got my equation. Let's use my equation. So now there's more information that needs to be done. So then, okay, so now we say, okay, well, how many, that means how many volunteers would we need to build a house in 50 hours, okay? So now we're going to look for how many volunteers, right? So let's just use our equation. That's easy. So we're going to go V equals, oh, I'm sorry, my bad. V times 50 equals 1,250, right? Because I put my 50 in for H. Divide by 50, right? Divide by 50. What is that? Divide by 50. And I get 25. So I need 25 volunteers to get the house done in 50 hours, okay? Provided I get good volunteers and I keep them organized, right? I mean, really, right? Okay, so real quick, I'm going to turn the page again. You guys ready for me to turn the page? Words. Look for the words, okay? Direct variation, this equation. Inverse variation, this equation. Jointly, it's going to have 3 or more variables, okay? Always find k first. You know, like Tammy said, if it is a direct variation, it has to go through the origin always, and it has to be straight. If it's inversely variation, it's going to look like a hyperbola. Fancy word, a hyperbola. Write it down. This graph is a hyperbola. That graph is this graph, it's not a parabola, it's a hyperbola. Okay? Hyperbole. Don't say that, please.